Okay, so we've got a little discussion going here, frictional force, normal force. And we have our person here pushing on the object. And they're pushing, I'm going to actually swap out the free body diagram. I'm going to do the free body diagram in a place where they aren't. Because what has to be true? If we're talking about static friction, is the object moving yet? Nope. So we know then that the force of static friction, as long as the object hasn't moved yet, it's equal to whatever the applied force is. This is not anything revolutionary. We've been talking about this. So can we do a sum of forces that gets us an expression that does not include Fs or Fn using the information here? Sure we can. Okay, so based on that little bit of algebra, can we write an expression there? So mu s is equal to, in terms of the things that we actually have, the force applied divided by the force of gravity. This is not, yeah, we know this, Moser, right? So you've looked at things on slopes. Now this is on flat surface. You've done lots of problems with things on slopes. Is normal force always equal to all of gravity? No. When we've got things on a slope, normal force tends to be equal to the portion that's on the y-axis. I now give you a slightly different scenario. Big person, little box. So, does this change anything about our frictional force? Well, let's look at this. And I'm going to actually copy this, but then we're going to do some changing. So, normal force, gravity, force of static friction stay the same. Where is the applied force here? It's something like that. Have you ever pushed an object like this? I push the laundry basket down the hall like this every Saturday morning. You know, you kind of lean into it and shove. Makes a really satisfying sound. So that changes our picture here. Does that change the expression that we could write here? And how so? So here's what I want you to do. Intuitively, without writing down the sum of forces, I want you to make your best guess. I want you to think about this, so pencils down for a second. Do you think that the normal force is going to be greater or lesser than it was on our first instance here? So now we'll pause. Now that you've paused for reflection, let's do the sum of forces. So I'm going to move all this up and out of the way. And sum of forces on the y. Still equal to 0. Equal to normal force minus force of gravity. Anything else? Yes. Also minus F applied y. Now, I didn't give you an angle here. We're just talking in generalities. We're not approaching specific numbers. But what this means is that the normal force here is equal to the magnitude of gravity plus the applied force times sine of whatever angle that force is being applied at. Now, there's our angle. So will that change the force of static friction? That's a question we're not going to answer. But it does change the normal force that goes into that equation. Is the force of static friction equal to the entire applied force? The only component that's on the same axis as the force of static friction is the force of static friction on the x-axis. So does this change our coefficient? These are good questions. These are questions we're going to investigate next week. Okay, so I'm going to leave this here as generality. I haven't dotted all the I's and crossed the T's. This is a conversation. I want you to start thinking about this in advance. Now let's look at one other scenario. Okay, so now we have a tiny person pushing a big box. Where's their force applied? Up. So all those same questions apply, okay? This is sort of a precursor, a hint to the mini lab that we're going to start probably Monday of next week. So tomorrow we will FIP. We'll walk through the FIP. We'll maybe do some mistake game stuff. We'll see. And then Monday I'm going to hand you the mini lab. I'll post it over the weekend because I'll post the rubric. You'll be able to see it. It's very much a lab where all your calculations, like every step of your calculations, is worth something. I think it's like 60 points, and like I said, it'll go in as a test. But this is sort of to juice the works, to get you thinking about some of the things that you'll need to demonstrate in the mini lab. Normal force changes sometimes, and you're going to actually calculate coefficients of friction for some objects and surface pairs in the high school. So, okay, I think that's about all the time we have today, and hopefully you get to the midpoint of the day and you no longer feel like that. You feel like this, like you're a giant person pushing a little box and you can do it, and it's all rolling downhill. No, not so much. Okay. Well, anyway, that's where we'll end our conversation today. We will FIP tomorrow.